Dear students, I am Paras Doshi, I am the director of Kushal classes and I am going to teach you physics and I will continue in electricity. Thank you. So in physics, the most important term is resistance. We have studied V equal to IR. R is resistance in this Ohm's law. Okay. What is the unit of resistance? SI unit. Ohm. So we can find the resistance R with the formula V by I. So in any circuit, if voltage is given, current flow we know, we can find out the resistance. Now the property of resistance, because in circuit we connect fan, we connect AC, we connect light, maybe geyser, also whatever things we connect, everything goes some resistance. So how the current will flow and how we'll measure the current. So it only depends on resistance because normally voltage is fixed. If you see the household voltage is 230 volt AC. So whatever current varies, it depends on the resistance, and we tell in physics resistance is load. How much load is there in house or factory? I will come to teach you in detail shortly. Normally in our house or any factory, the devices are connected in parallel. Why we connect in parallel? So that every device gets full voltage. So it gives full efficiency. But in certain circuits, we connect resistance series also. So today we are going to use how the application of series resistance and parallel resistance. I am going to teach you. So at first, the series connection I will teach you, then I will go to parallel connection and how to calculate resistance in series connection and parallel connection. The resistance or resistances connected in series connection. So suppose these are three resistors, namely R1, R2 and R3. There can be n number of resistance, but I have shown you three resistance. So this is the starting and this is ending point, this is start point and ending, start and ending. So if you connect the end point of first resistance to start of second and end of second with the start of third, then this connection is known as series connection. Things are in series. This is a voltage source. So V is the voltage. This is a meter which measures current. Its name is ammeter. So this is connected like this, plus minus, plus minus. When we switch on this circuit, means this is switching on, made on. Then suppose I current flows. Now this voltage will be divided in across these three resistances, and you will measure the voltage. So there is a voltmeter V1 which measures voltage drop across R1 resistance. Then another voltmeter which measures voltage drop across R2 resistance. And another voltmeter V3 which will measure the voltage drop across R3 resistance. Now you can see in this circuit, see whenever we switch on the switch, then the voltage will flow applied and current will flow. Suppose I current is flowing, we will measure the current through this ammeter. So suppose current is flowing. Now as per common sense, see there is only one path. This current will flow like this, it will like this. So I will be here, same current will be here, same current will be here, and this current will come like this. Because series, just like a water pipe, water is coming, so there is no other path. This is only just to measure voltmeter. Current can't go this because there is very high resistance across this. So what we learn from this, in series connection of resistances, current will be same throughout. So the most important point, number one, to remember, current remains same. At the same time, so when current is same, voltage will be divided. This voltage V will be divided across R1, R2, R3 means V1, V2 and V3. So current remains same, then voltage will be divided. So if current is same, voltage will be divided. So our main voltage is V. So we can write V equal to V1 plus V2 plus V3. So this is equation 1. I hope you understood. This voltage V is divided in V1, V2, V3. But H per Ohm's law, V equal to IR. Therefore, we can write V1 will be equal to I R1. V equal to IR. Now this V1 voltage, I is the current, R is resistance. So V1 equal to IR1. V2 equal to IR2. You can see V2. This voltage will measure the drop across R2 resistance, so R2 into I. Current is same. And V3 equal to IR3. V1, V2, V3 and V equal to IR. So if we substitute these values of voltage in equation 1, then what will happen? Instead of V, I can write IR. V1, I can write IR1, IR2 plus IR3. I have substituted value of V1, V2, V3 in equation 1. So V equal to IR, IR1, IR2, IR3. Now suppose I kept I common, then R1 plus R2 plus R3. This is equal to IR. So I got cancelled. So what we get? R equal to R plus R2 plus R3. This R is series resistance. So this series resistance Rs equal to R1 plus R2 plus R3. So this is our main formula. When the resistances are connected in series, the equivalent resistance, final resistance will be sum of their individual resistance. So Rs equal to R1 plus R2 plus R3. So I hope you understood that how we can derive the formula in series circuit of resistances. Okay, now we'll go to connection in parallel. So parallel connection. This is resistance R1. This is resistance R2. This is resistance R3. These are the beginning points and these are the end points. So if we connect all these three beginning point at one point and the ending point at one point, then these resistors are connected in parallel. This is parallel circuit because beginning is same and end is same. Again we are connecting the voltage V across the circuit. So you can see this voltage will go to all the resistors, same point. Suppose this point is A, this point is B. Then R1 resistance will also get V volt, R2 will also get V volt, and R3 will also get V volt. And if you want to measure, we can put one voltmeter across it. So it will measure the whatever voltage is there, it will measure this. Now again ammeter is measuring current I. So I current is going here. Now with the common sense you can see this I current will be divided in these three paths. There are three pipes. This is main pipe. So current will go in these three paths. So I connect 3 ammeter here. So this is measuring current I1, I2, I3. So this I current is divided in I1, I2, I3. It will flow like this. Here also it will be I1, I2, I3. At this point this will get combined and it will be I. When I connect this circuit. So this is the circuit diagram for resistances connected in parallel. Now with just common sense or just by thinking we can see everything is very crystal clear. Here voltage is same. See the voltage is same. V volt, it is all across the resistance we are giving voltage. But here current is getting divided. So by this figure itself you can conclude number one, in series, in parallel connections of resistance, number one, voltage remains same. Throughout circuit. And number two, so if voltage is same, then current will divide. In series it was just opposite, current was same, voltage divided. It is here now voltage remains same throughout circuit, then current will be divided. So these are the main point to remember. Now current is divided. So what we can write? I equal to I1 plus I2 plus I3. Okay, now but H per Ohm's law, V equal to IR, so I will be equal to V by R. Similarly, I1 will be equal to V by R1, I2 will be equal to V by R2, and I3 will be equal to V bar R3. V equal to IR, so I equal to V by R, I1 V by R1, I2 V by R2, and I3 V by R3. See, voltage is same, this across this, so I1 will be equal to V by R1, I2 will be equal to V by R2, and I3 will be equal to V by R3. Now we will substitute these values and we will find out the resistance in parallel. So I equal to I1 plus I2 plus I3. Now by substituting the values of I, I1, I2, I3 and I, V by R equal to V by R1 plus V by R2 plus V by R3. So V by R will be equal to, if I take V as common, 1 by R1 plus 1 by R2 plus 1 by R3. Now V cancel, so 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So this is parallel connection. So if I put R as Rp, then in parallel connections, the effective equivalent resistance will be the reciprocal of it. 1 by R1 will be equal to 1 upon R1, 1 upon R2 or plus 1 upon Rp. So this is our final formula. Means resistance will be added in reciprocal. Now here I will give one example how to find the equivalent resistance in parallel circuit. So in C it was very easy. R equal to R1 plus R2 plus R3. So suppose R1 is 10, R2 is 15, R3 is 20. You can add 10 plus 15, 20, 5 plus 20, 45. So series is just addition. But in parallel, how much we'll get, just find out. Suppose R1 is equal to 10, R R2 is 15 and R3 is 20 ohms. Then 1 upon Rp will be equal to 1 upon 10 plus 1 upon 15 plus 1 upon 20. Now we'll add by taking LCM. Now 10, 20, 15 LCM will be 60. So 6 plus 4 plus 3. 1 upon Rp. Parallel resistance. So it will comes out to be 13 upon 60. 1 upon Rp 13 over 60. So Rp will be equal to 60 by 13. So it will be approximately 4.61 ohm. See, the final resistance is 4.6. Whereas if you see the individual, R1 is 10, 15, R2 and 30. Means the parallel resistance will be lesser than any one of them. So in parallel resistance will be always less, and if resistance is less, current will be more. And for your knowledge, except certain things where series connections we use, like we use small bulbs in series for the decoration, where the voltage is less to each bulb. Okay, so they are voltage divided. But in most of the household application or factories, things are connected in parallel. I hope you understood. If you have any doubt, then you can ask me by doing phone. My phone number is 98424548. Thank you.